All right, good morning. Welcome back to Calculus 2. We are looking at our final exam review here. This problem asks us to figure out the area of the inner loop of the function r is equal to 1 plus 2 sine theta. The first thing I'm going to do is go ahead and draw this thing. You don't really have to do this, but I'd like to go ahead and draw it. So what we're going to do is we're going to go ahead and draw a polar coordinate graph here. So when theta is equal to 0, we're looking in this direction. Sine of 0 is 0, so we just have r is equal to 1. So we're going to go over here. Uh, when so we have theta is equal to 0. Theta is equal to pi over 2. We're just going to check 4 points around here. Uh, when theta is equal to pi over 2, sine of pi over 2 is 1. So we have r is equal to 1 plus 2, which is equal to 3. We have r is equal to 1 plus 0, which is equal to 1. So we have 1, 2, 3. So we're going to be doing something like this. Okay. When theta is equal to pi, again, we're just going around the other direction here. So we looked up, we're looking over. Okay, so we're looking over here. Okay, we have r is equal to 1 plus sine of 0 is, or sine of pi rather, is 0. So we have r goes back to 1. So we're going to be over here again. Okay, and now when theta is equal to 3 pi over 2, we're looking straight down. Okay, we're looking down here now. We have r is equal to 1. Sine of 3 pi over 2 is negative 1. So we have r is equal to 1 minus 2, which is equal to negative 1. So even though we're looking down, we have to step backwards because it's down direction, but it's negative. So what's going to happen here is it's going to come through the origin. It's going to hit this little piece in here, and it's going to come back out so it can ramp back around and kind of come around and do something like this. So the inner loop I'm talking about is like this little ugula type thing looking over here, okay? So that's what we're looking for. So what we have to do is we have to figure out where exactly does it cross the 0. So what I'm going to do is I'm going to say, let's set it equal to 0. So we have 1 plus 2 sine theta is equal to 0. Okay, let's see here if I can get, there we go. R is equal to, we have 1 plus 2 sine theta equals 0. So we have 2 sine theta is equal to negative 1. Sine theta is equal to negative 1/2. That's an angle from your unit circle, all right? But we're looking at our picture here, which is why we do the picture. We want this to be in quadrant 3 or quadrant 4, okay? That's what's going on here. So we need somebody whose reference angle is a half, right? The side of that reference angle is a half. So we're looking at a pi over 6. So what we're going to say is that theta is equal to 7 pi over 6. That's in the third quadrant. And then we're going to say 11 pi over 6. That's in the fourth quadrant. So my limits of integration are going to be 7 pi over 6 and 11 pi over 6. Okay. So let's go ahead and set up our integrals. So our area is equal to 1/2 integral from 7 pi over 6 to 11 pi over 6. And then we have 1 plus, what is it? 1 plus 2 sine theta squared, right? Because it's a is equal to 1/2 r squared d theta, d theta. Okay, and that's what we're going to be working with. All right. We can't integrate the way it looks like this. There's no use substitution or anything like that. We're going to have to go ahead and multiply this thing out. Okay, so we're going to say we have 1/2 integral from 7 pi over 6 to 11 pi over 6. All right, and then we multiply this out. That's going to be 1 plus 4 sine theta plus 4 sine squared theta all times d theta. Okay, well, we can't quite integrate this because sine squared theta doesn't really have a nice integral for us. We have to do a substitution before we get there. If you go back and remember that cosine of 2 theta is equal to 1 minus 2 sine squared theta. That's the pathway through this thing. So I'm going to push my side squared on the left side and everything else on the right side. So we have 2 sine squared theta is equal to 1 minus cosine of 2 theta. Okay. And since we need 4 of them, I'm just going to multiply by 2. So we have 4 sine squared theta is equal to 2 minus 2 cosine 2 theta. Right? And that's what we're going to do with that. So here we have 1/2 integral 7 pi over 6 to 11 pi over 6. We have 1 plus 4 sine theta plus 2 minus 2 cosine 2 theta. All right? And that's what we've got for that right now, d theta. All right, there's some terms we can combine now. So we have half Integral 7 pi over 6 to 11 pi over 6. Okay, we have 1 plus 4 sine theta. Actually, well, 1. 1 plus 2 is equal to 3. Let's go ahead and change that to a 3 and make it look like a 3 rather than a B. So we got a 3, okay, minus 2 cosine 2 theta d theta. Oh, that's a reasonable integral we can deal with. Let's go ahead and put this 1/2 in here so I can deal with that. Okay, so we're going to say that we've got integral from 7 pi over 6 to 11 pi over 6. We've got 3/2 plus 2 sine theta minus cosine of 2 theta. Okay, and that's pretty much what we're dealing with at this point. Okay, this is not too bad of an integral, so let's go ahead and integrate that. So what we have here, we've got, okay, let's like this. We go ahead, we can say this is 3/2 theta, okay? And then we have minus, because we're integrating sine, so we need a minus 2 cosine theta. And then we're going to say minus 1/2 sine of 2 theta evaluated from 7 pi over 6 to 11 pi over 6. Okay, so that's the setup. The only thing left now is doing the arithmetic. If you got this far with this problem, you're doing fantastic. Okay, the arithmetic is always the hardest part, and then this is like honestly punching this thing into a calculator is not going to be too bad of a problem. It is for me, but for you guys, punching this into a calculator is not going to be too bad. So we're just going to be able to say, okay, we've got let's see here. Let's just set this up. We've got 3 over 2 times 11 pi over 6 minus 2 cosine of 11 pi over 6 minus 1/2 sine of, we're going to multiply this by 2. That's going to be 11 pi over 3, right? Because 2 times 1 is 6 is going to be a third. Minus, and then we're going to say 3/2. Let's go ahead and put a big bracket here. Times 7 pi over 6 minus 2 cosine of 7 pi over 6 minus 1/2 sine of 7 pi over 3. All right, and that's pretty much where we are with this thing. All right, let's see what we got here. Next thing, we'll go ahead and we'll do some magic around here. So let's see, this 3 and that will cancel out a little bit. So we can go ahead and we can just go ahead and do this. So we'll say we have 33 pi over 12, because I know it's going to subtract out some of the stuff over here. So I'm going to leave it on, I'm not going to leave it. I'm going to leave it in unreduced form for just a moment. Minus, and then you could use a calculator. You're fine to do that, but it's going to be minus 2 square root of 3 over 2. Okay. And then we're going to have, this is third quadrant stuff, right? Let's see here what happened with this one. 11 pi over 6. This was fourth quadrant, so cosine is positive, so this doesn't change. Let's see, for 11 pi over 3, right? We have 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3. So that's going to be a negative number as well, I think. 11 pi over 3 sitting over there. So we're going to change our sign. So this is going to be a plus 1/2. And then sine of 11 pi over 3 is going to give me, again, square root of 3 over 2. Okay. And that's evaluated at 11 pi over 6. Okay. Minus. All right. And then we're going to go ahead and deal with the same thing for this one. So I've got 21 pi over 2. 21. Get here. 3. Let's see here. We got 33. What do we have for this one? Okay. I don't know why I did it this way, but I did. Okay. We have 21 pi over 2. Oh, no, we don't. We have something else. Okay. Well, let's go ahead. We have 21 pi over 6. Okay. So again, I know that these are going to cancel out a little bit. Okay. And then we're plugging this in for, again, 7 pi over 6. 7 pi over 6 is 1 pi over 6, 2 pi over 6, 3 pi, oh no, 1 pi over 6 is here, 2 pi over 6, 3 pi over 6 is straight up, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6. It's in the third quadrant. Okay. So this is going to be a negative number here, so we're going to have to change our sign. So we're going to have plus, and we have this pi over 6, so it's going to be 2, and we have square root of 3 over 2, I believe. Yes. Okay. Some stuff is going to cancel, and then again, we are in our 7 pi over 3. Let's see where that is. We have 1 pi over 3, 2 pi over 3, 3 pi over 3, which is pi, 4 pi over 3, 5 pi over 3, 6 pi over 3, which is our, no, maybe 2 pi, 7 pi over 3, first quadrant. So we have minus 1/2 pi over 3. That's also going to be the square root of 3 over 2. Okay. And again, we're just going to work through this arithmetic. So that effectively the problem is over, but we're going to tap it off here. 33 minus 12, or 21 rather. We can go ahead and do that one. So we can just figure that out. So we have 33 minus 21. Just got my handy little calculator here. That gives me 12. So we have 12 pi over 6. Okay. So let's see. We have 12 pi over 6, which is just going to be 2 pi, right? So that's going to be 2 pi. Okay. And then we've got to go ahead and figure out like a lot of this stuff. So we have minus the square root of 3, right? Because these guys are going to cancel, plus square root of 3 over 4. Okay. And then we have to be kind of careful. We use this one up. We're going to distribute the negative sign. So minus square root of 3. Okay. And again, distribute the negative sign. So we're going to end up with plus square root of 3 over 4. Okay. And then that's pretty much where we are at with figuring this thing out. So we've got 2 pi minus 2 square roots of 3. Okay. And then we have plus square root of 3 over 2. Okay. And again, we could probably figure some things out here. We could say we have 2, make that a 4. We're going to be able to do something like this. So let's, oh, why did I do that? Yeah, no, we're okay. So we have 2 over 4. And then we have multiplying this one by 4 over 4. So we have minus 8 root 3 over 4 plus 2 root 3 over 4. That's going to be minus 6 root 3 over 4, which is going to be 2 pi minus, and then we're going to cancel some stuff out. So that's just going to be 3 root 3 over 2. And that's our answer for how you do a problem like this. Okay. So important parts is we got our limits of integration. We figured out where and what our region was going to be. That's what we integrated. It's just a little part here. We applied our 1/2 r squared d theta, put it into an integratable form, integrated it, and then applied the numbers in here so we could do our arithmetic. Okay. And that's pretty much how you do that kind of a problem. Thank you very much for watching. I'll see you in the next problem. Thank you very much. Good luck.